Section 6.4, problems 1 through 4. Number 1 says, consider a normal distribution with a mean of 40 and a standard deviation of 8. All right, so the mean's 40, standard deviation is 8. What is the probability that a value selected at random from this distribution is greater than 40? All right, here's what we're asked for in A, well, in problem number 1, right? In problem number 1, what is the probability that X is greater than 40? Now I'm going to use my calculator to do this, but I'm in the habit of drawing pictures of every time I do this because it really helps me to see exactly what I want. All right, so we're in X's. So I'll draw the normal curve. Now, what's the mean here? Come back over here. Oh, well, the mean is 40. Okay, well, we really don't have to do too much work here. The mean is 40. So we're right here now at 40. And we're looking for X greater than 40. All right, so I want the probability that X is greater than 40. So I want to be in this interval right here. What is the probability that a randomly chosen value of X puts us in this interval? Well, that probability of being in this interval, that's measured by this area right there, right above the interval. Now this one, in this case, turns out to be what? We don't have to do any calculations at all because we're halfway there. This turns out to be 0.5. But now let's just suppose it wasn't right at 40 and we had to do some work here. All right, I'm going to use the normal distribution on my calculator. So here's where I'm going to go. I'm going to press second, vars. And I want variables because this is where my distribution is. And I want to get item number 2, which is our normal CDF. All right, and then from normal CDF, we're going to get a lower, an upper, a mu, and a sigma. Now, what's the lower bound here? Well, the lower bound, all right, what are we going to put for lower? Well, I come over here to my problem, and what do we want? We want greater than 40. Now, I wrote that down over here, and I have a picture that shows me exactly what I want. So my lower bound here is 40, so I type in a 40. Now, what's the upper bound? I can see on my picture that this goes out to infinity, right? So I have to get that infinity in there, and I can do that by typing the E99. And remember to get that E, I'll do it down here at the bottom left. To get the E, you press second, and then you look for the 7 key, and right above the 7 key, there's a comma key. And right on the comma, there's EE. That's why you press second to get there. But when you press EE, you just get one E. And then type 99. Now the mean. Look at the mean of this distribution here. So I'm looking for the mean. I follow it up to my problem. The mean is 40. Standard deviation is 8. So I'm going to put in a 40 and an 8. And then I'll go to paste and enter. And let's compute. Now, my calculator is showing this, 0.49999, right, off forever. Okay, so what is that? Well, that's 0.5. And we are supposed to do what? We are supposed to, I'm looking for rounding, round to 2 decimal places. Really? Just 2 decimal places? Okay, so how about 0.50? So back up here at the top of my problem, I'm going to claim that this answer is 0.50, right? So 50% of the area is under there, which we could tell just by looking. And what's this problem 3? Suppose 95% of the area lies to the left of Z. Okay, well now 95% lies to the left of Z. So in that case, let's draw the picture. I think we probably have an idea of what this is going to be from the last problem we did. All right, there's 0. Now I got to find a Z that 95% of the area is to the left. Okay, so if I put the Z here, start at 0, that's a good place. 95% to the left, well, if I go to the left, I'm only getting 50%, so it's not there. If I go over here, that area is to the left, that's less than 50%, so it's not there. I'm going to have to put the Z-score out here, because that way I could get 95% of the area right there. So what do you know about Z? Z is positive. So let's go up to problem number 3, and we will say that z is positive, and there's our answer for that one. Now, question 4 says, assume that x has a normal distribution. All right, so we've got the normal curve, the bell-shaped curve, with a specified mean and standard deviation. All right, they're just telling us we got a normal curve with some mean, some standard deviation. Now, find the indicated probability. All right, so here's what we know. I'm going to draw this picture. I will draw a normal curve. Now, they're telling us the mean, right? The mean, they're telling us the mean is 8, standard deviation is 6. So draw the normal curve. Get your bell-shaped here. The mean, the high point is 8. Standard deviation is 6, okay? So mu is 8. Sigma is 6. And what we want is this. Find the probability that x, a randomly chosen value of x, is between 5 and 17. All right, now, on your picture, 8 is right here, okay? So I'm going to draw this on the picture. There's 8. Now, 5 is to the left, 17 is to the right. So here's what my picture looks like. 5 is over here, 17 is over here, and I want the probability that if I randomly choose, right, here's the x's, just randomly choose an x. Now remember, x's are on this horizontal axis. Those are the x's. What's the probability that you randomly pick an x and it lands in this interval? Right, you pick an x, maybe it's here, or here, or here, or here, just somewhere in this interval, right? So what's the probability that you land in that interval right there? That probability is measured by that area right there, and we can get that on our calculator, so let's do it. Now I'm just going to say where to go, right? You're going to go to normal, CDF, the lower bound, that's the 5, the upper bound, that's your 17, the mean in this problem is 8, standard deviation is 6, so type that in, paste, and calculate. When I did that, I got 0.62465, and look for round off. There's my answer. What are we supposed to round off to? 4 decimal places. All right, it's the probability, so we're going to round off to 4 decimal places. So over here, I've got 1, 2, 3, 4. Now, that's a 5, so normal rounding, you'd round up. But in statistical rounding, you round to an even digit. So I'm going to go with 6246.